Quantum chemical descriptors are quantitative values calculated using quantum mechanics, say semi-empirical, Hartree-Fock, ab initio, or DFT. It's easier to determine computationally than experimental descriptors. Quantum chemical descriptors are molecular orbital energy, HOMO and LOMO, and the difference between HOMO and LOMO, that's called E-gap, nucleophilic, electrophilic, and radical, dipole moment, heteroformation, polarizability, electron affinity, ionization potential, energy protonation, electrostatic potential, log B, vibrational energy. All these descriptors can be determined computationally using software. Partition coefficient, log B. The partition coefficient is the ratio of concentration of a compound in a mixture of two immiscible solvents at equilibrium, like octanol water system. Log B can be determined computationally by using softwares, different softwares like HyperChem, and can be determined experimentally using gas chromatography. Molecular descriptors can be calculated using Dragon application. It's a free software. Make tables containing data of a set of compounds, their calculated descriptors, and their target properties using Excel, SPSS, Minitab, or any software based on statistical analysis. We come to the fourth step, selection of the suitable descriptors for model for QSAR or Qspr model. We use principal component analysis. What's principal component analysis? Principal component analysis is dimensionally reduction method. Dimensionally reduction method reduce the number of several columns into two components. Say all variable descriptors in the table is reduced into component BC1 and BC2. They are still containing the most information in the large set. When the two variables are close to each other, they correlated significantly positive. On contrary, if the variable on the opposite side of the center, they are significantly negative correlated. Higher correlation coefficient is significant regardless of their sign, positive or negative. The fifth step, mathematical modeling using multiple regression analysis. Multiple regression analysis is a statistical technique that can be used to analyze the relation between the property or activity values of a set of compounds and their several descriptors. To get an appropriate mathematical model, we should split the data set of compounds into three independent sets. The first one, training set. Training set give us the mathematical equation of Qspr. Help us making reduction. The second set, validation set, that's called internal validation. The validation set is a set of data separated from the training set that is used to validate our model performance during training. The last set, test set, its final step in evaluating the model performance using an external validation. The output of multiple linear regression analysis are three tables: regression statistic table, ANOVA table, regression coefficient. The given mathematical model includes two groups of parameters: the calculated descriptors D and the regression coefficient beta. The criteria to evaluate the given mathematical model: the standard error should be low, R square shouldn't be less than 0.9 for medicinal studies and not less than 0.95 for other studies. If the p-values is more than 0.05, then the result is not significant. If the p-value is less than 0.05, then the result is significant. Finally, we obtained the evaluated mathematical model. The property or activity of any compound out of the set can be calculated by the obtained descriptors GI and the obtained regression coefficients.